Here we have a square ABCD and two half circles of the same radius. We have a line EH that goes through the top of one of the circles at point F. It also intersects the side CD at point G. We know FG is 2, GH is 1. We would like to find the angle between EH and CD. In one additional condition is the length of the arc EA and CH are the same. So what can we do here? Okay, let's continue. First of all, notice that if we take this right half circle and make it a full circle, it's going to go through point F. Now we're going to draw a horizontal line through point F. We get FK. And point O, the center of the right circle, is on the line FK. FK is actually diameter. Now we're going to connect K and H. And if you look at the triangle FHK, that's an inscribed triangle. And one of the sides of this triangle is a diameter. And that means that the angle opposite of the diameter is 90 degrees. That follows from Thales theorem or inscribed angle theorem. If you're not familiar with them, I left a link. You can go there and get the information you need. Now let's consider, okay, let's do it again. Let's look at triangle FGO and triangle FKH. Those triangles have two congruent angles. They're both right triangles. Just a second. Okay, let's continue. Let's consider triangle FGO and triangle FKH. Those triangles have two congruent angles. They're both right triangles. And also they share the angle F. So those triangles are similar. And we know in similar triangles, ratios of respective sides should be the same. So if we look at the ratio of the sides opposite of 90-degree angle, in the small triangle is going to be side FG, in the large triangle is going to be side FK, and also look at the ratio of the sides opposite of this red angle. In the small triangle is going to be side FO. In the large triangle, this red angle is angle K. So the side opposite of it is FH. And those two ratios should be the same, since triangles are similar. Now we know FG is 2, FK is diameter, FO is radius, FH is 3. So we can plug this thing in and get the expression for FO, for the radius. And FO will be square root of 3. Now, if we divide FO by FG, we get square root of 3 over 2. And that is a sine of the angle we're interested in, because it's a ratio of the opposite leg to the hypotenuse. Now, if you're not familiar with, okay, let's do it again. Now, if you know, okay, let's do it again. If you know trigonometry, you should quickly say what this angle should be. If you don't know trigonometry, we can make an additional step. In this triangle FGO, we can use Pythagorean theorem to find the side GO, and that will be 1. And now we found a triangle, right triangle, where one of the legs is half of the hypotenuse. And we know that happens when the angle opposite of that leg is 30 degrees. It means that GFO is 30 degrees. But that means the angle we're interested in is 60 degrees. And we're done. Now, the funny thing about this problem is there's additional condition that AE should be the same as CH, which we haven't used anywhere. If you watched the previous video I posted, you may be wondering if it's kind of a tricky problem. And maybe, although we found that this angle of 60 degrees, if we try to check whether AE and CH are the same, we'll find that that's not the case, and that would mean that this geometrical construction is not possible, and we cannot find this angle. Now let's check if that's true or not, if AE equals to CH. Actually, what we're going to do, we're going to solve a little bit more general problem. Okay, let's continue. We will forget that this angle is 60 degrees. We'll forget that FG is 2, GH is 1. All we're going to do is we're going to look at AE, and we'll try to figure out whether CH is the same length as AE or not. Now, what does it mean that AE and CH are the same length? That really means that the central angle, which inscribed, okay, notice that again. This means that the angle, okay, let's do it again. Okay, let's do it again. AE will be the same length as CH if and only if the central angles that intercept those arcs are congruent. So if I is the center of this bottom half circle, in this case the angle AIE should be congruent to angle COH. That happens, okay, let's continue. Okay, let's continue. This happens because both circles have the same radius. Now, how can we prove this fact? Okay, let's dig in. So let's consider the case when we don't know whether AE and CH are the same length. Let's assume we have some AE, and there's a corresponding angle alpha, angle AIE. And in general, it could be anything we want, between 0 and 90 degrees. Now let's connect point F and I. That's going to be a vertical line. It means that angle AIF is 90 degrees. And that means this angle right here is 90 minus alpha. Triangle A, okay, let's do it again. Triangle EA, okay, let's do it again. Triangle EIF is an isosceles triangle. EI and FI are radii, and therefore angles at the base should be the same, and that means that angle F should be 45 plus alpha over 2. Now that means that the angle right here, angle G, goes again. That means that the angle right here, angle HFO, should be 45 minus alpha over 2. And that's because the sum of this angle, and this third angle of 90 degrees should be 180 degrees. Triangle FHO is an isosceles triangle. Angles at the base should be the same, so this angle H here should be also 45 minus alpha over 2. And that makes this angle right here, FOH, to be 90 plus alpha. Now this part of this angle right here is 90 degrees. Therefore, the part right here should be alpha. So we proved that this angle right here and angle right here have the same measure. And that means that the arcs they intercept are the same. Notice, in this proof, we did not assume that alpha any specific angle. It could be, in fact, any angle we want. Now it is easy. Okay. Go away. I'm busy. I didn't finish yet. You're messing up my video.
No, that
Yes,
would be
you are.
the redneck across the street.
Now he's done already. Now you're doing it. So let's continue. Let's continue. So we show that no matter what this line EH is, as long as it goes through point F, AE should be the same as CH. That really means this condition is not necessary for anything. This condition doesn't give us any information. Okay, let's dig in. This means this condition doesn't give us any additional information. This condition is redundant for any purposes. And the real question now is why whoever created this problem put this condition here. If you have any ideas, please leave a comment.